Recording in progress.
Hello, dear students. This is your Engineering Mathematics 3 lecture. Today we are going to start 5th unit, probability and probability distribution. Now the topic, probability distribution. We know that frequency distribution gives tabulated values of x and corresponding frequencies. And the probability distribution gives tabulated values of x and the corresponding probabilities. So this is the difference between probability distribution and frequency distribution. In frequency distribution, with the observations, means with the values of x, the corresponding frequencies are given. And in probability distribution, with the observations, that corresponding probabilities are given. So this is the difference between probability distribution and frequency distribution. Now we are going to discuss 3 types of probability distributions here in this unit. That first one is binomial distribution, binomial probability distribution. See, what is binomial probability distribution? The experiment or a trial which has only 2 outcomes, a success or failure, with P as the probability of success and Q as the probability of failure. See, the experiment or a trial in which has only 2 outcomes, either a success or failure, where P is the probability of success and Q is the probability of failure. Since there are only 2 outcomes, so the probability of success means P plus probability of failure means that is Q. The addition is equal to 1. P plus Q is equal to 1, where P is the probability of success, Q is the probability of failure, and the addition is equal to 1. Because in binomial distribution, there are only 2 outcomes, either success or failure. Here binomial, in binomial distribution, bi means 2, means it has only 2 outcomes, either success or failure. So probability of success plus probability of failure is equal to 1. Okay. Now the probability of R success in n trials is NCR into P raised to R into Q raised to n minus R. See, probability of R success. Suppose or consider n number of trials. In n number of trials, suppose R times you are getting success. Then the probability of getting success R times in n number of trials is given by NCR. NCR means combination. NCR into P raised to R into Q raised to n minus R. You know what is P and what is Q. P is probability of success and Q is probability of failure. Okay. This formula gives probability of R is equal to 0, 1, 2, 3 up to n. It is success in n trials. So binomial probability distribution is denoted by its notation, means the notation of binomial probability distribution is there. B of NPR, or you may write here beta NPR. N means number of trials, P means probability of success, and R means number of times you are getting success out of n number of trials. Means R, the number of successes you are getting out of n number of trials. And the formula is given by beta or B of NPR is equal to NCR into P raised to R into Q raised to n minus R. So this is the formula of binomial distribution. And you know what is NCR. NCR means it is equal to n factorial upon R factorial into n minus R bracket complete factorial. So this is the formula of NCR. Okay. Now see the example on binomial distribution. An unbiased coin is thrown 10 times. Find the probability of getting exactly 6 heads, at least 6 heads. See, our aim is here, you find the probability of getting exactly 6 heads or at least 6 heads. Now, an unbiased coin is thrown 10 times. This number of trials n is equal to 10. And here the probability, standard probability of coin, when we toss the coin in air, the standard probability of getting head is obviously 1 by 2, because there are only 2 outcomes, and the probability of getting head out of that 2 outcomes is 1. So probability is equal to 1 by 2. The probability of getting success means probability of getting head when the coin is tossed in air is equal to 1 by 2. This is the standard probability of tossing the coin in air. Now you know the probability of success means probability of getting head is 1 by 2. So you can find the probability of getting failure means you are not getting head. It is 1 minus p, because when we toss the coin in air there are only two outcomes and the probability of success is 1 by 2. So obviously the probability of failure will be 1 minus probability of success is 1 minus p, and so it is 1 minus 1 by 2 is equal to half. So probability of failure is 1 by 2, probability of success is 1 by 2. Okay. Now our aim is find the probability of getting exactly 6 heads, and the coin is tossed in air 10 times, means the number of trials n is equal to 10. So the value of n, small n, is 10. Now, probability of getting exactly 6 heads is equal to, means the value of success is 6. R is equal to 6, because we represent the success by the letter R. Out of 10 times, you are getting 6 times heads, means the value of R is equal to 6. Now we want the probability of getting exactly 6 heads, means P of R is equal to 6 is equal to. Now you know the formula for binomial distribution. It is NCR to P raised to R into Q raised to N minus R. Now you know the value of N. N is 10. C R. R means number of successes. It is equal to 6, exactly 6. So 10 C6 into P. P is probability of success. It is 1 by 2. And again the value of R to the power 6. Q. Q is again 1 by 2 to the power N minus R. N is 10. R is 6. So 10 minus 6. So it is equal to 10 C6 1 by 2 raised to 6 into 1 by 2 raised to 4. Now here 1 by 2 base is same, because it is a coincident here that the value of P and Q both are equal. So base is same. Here 1 by 2 raised to 6 into 1 by 2 raised to 4. So we can do the addition of indices. 1 by 2 raised to 6 plus 4, 10. So the answer is 10 C6 into 1 by 2 raised to 10. You can calculate this value from the calculator. 10 C6. You know how to calculate 10 C6. This is the formula. NCR is equal to N factorial upon R factorial into N minus R bracket complete factorial. So using this formula, you can calculate 10 C6 into 1 by 2 raised to 10. You will get the probability of getting exactly 6 heads. Now, second aim in the same example is probability of getting at least 6 heads. See, we are going to find here the probability of getting at least 6 heads. So at least means minimum 6 times you will get heads, means maximum you will get 10 times heads, because the number of trials is equal to n is equal to 10. We are tossing the coin in air 10 times. So the maximum time you will get heads 10 times. Here we want the probability of getting at least 6, means you start from 6, at least 6. Probability of R is equal to 6 plus you may get 7 times head. So you find probability of R is equal to 7. You may get R is equal to 8, means 8 times head. So probability of R is equal to 8. Probability of R is equal to 9. Probability of R is equal to 10. So maximum 10 times you will get heads. So you just add the probability of all from R is equal to 6 to R is equal to 10. Because these all are exclusive events, independent events. So you just find the probabilities of for every R, which R is equal to 6, 7, 8, 9, 10, and then you add all the terms. Okay, so it is equal to 10, R is equal to 6. Now you know the formula for binomial distribution. It is NCR into P raised to R into Q raised to N minus R. So here R is equal to 6, so it is NCR. N means number of trials, it is 10. N is equal to 10. So 10 C6 into 1 by 2 raised to P raised to R means 1 by 2 raised to 6 into Q raised to R, N minus R means 1 by 2 raised to 4 plus. Now probability of R is equal to 7. P of R is equal to 7 means the formula is here 10C7 1 by 2 raised to 7 into 1 by 2 raised to 3. Similarly, you find the probability of R is equal to 8. It is 10C8 into 1 by 2 raised to 8, 1 by 2 raised to 2. Then you find the probability of R is equal to 9. The same formula we are using here, NCR into P raised to R into Q raised to N minus R. Now the value of R is 9 here. So the result, the formula becomes 10C9 into 1 by 2 raised to 9 into 1 by 2 raised to 1. Because the value of P is 1 by 2 and the value of Q is also 1 by 2. And the value of R is 9. So 1 by 2 raised to 9, 1 by 2 raised to 1. Then you find the probability of R is equal to 10. It is 10C10 into P raised to R, 1 by 2 raised to 10, because the value of R is 10 here, and Q raised to N minus R, 1 by 2 raised to Q raised to N minus R, N is 10. And the value of R is also 10. 10 minus 10, 0. So 1 by 2 raised to 0. So you just simplify all the terms. Then see here, P and Q are same. Therefore, you can add the indices, the powers of that P and Q, because P and Q are same, 1 by 2, 1 by 2. So in first term, 6 plus 4 is 10. Second term, 7 plus 3 is 10. In third term, 8 plus 2 is 10. In fourth, 9 plus 1 is 10. And in last, 10 plus 0. In last term, the 1 by 2, the power of Q is 0 and the power of P is 10. So the addition is again 10. So in every term, the power of 1 by 2 we are getting is 10, because there are n number of times. And then you find a value of 10C6 into 1 by 2 raised to 10 plus 10C7 into 1 by 2 raised to 10, and so on. You find the values of every term. You add all the terms. That will be the probability of getting at least 6 heads. On using calculator, you can find the values of all the terms here. So this is the first example. Now the next example is probability of man age 60 years will live for 70 years is 1 by 10. Find the probability of 5 men selected at random. 2 will live for 70 years. Here there is one correction. There is one correction here. Here the main, the spelling is wrong here. Men. Men. 5 men selected at random, 2 will live for 70 years. Okay. Here the probability of man age 60 years will live for 70 years is equal to P is equal to 1 by 10. Here in this example, that standard probability of a man age 60 years will live for 70 years is given, means the value of P is 1 by 10. In previous example, the standard probability was not given, but we know that when we toss the coin in air, then the probability of getting head is 50%, because there are only two outcomes, either you will get head or tail. So there the probability, standard probability is 1 by 2. It was not given, but we can easily find there the probability of getting head. But here in this example, the standard probability is already given. The probability of man aged 60 years will live for 70 years is 1 by 10. So this is your probability of success. What is our success? The man of 60 years will live for 70 years. That is our success. And the probability of that success is 1 by 10. Now from P, you can find the value of Q, probability of failure. Q is 1 minus P. So P is 1 by 10. So 1 minus 1 by 10 is equal to 9 by 10. So this is the probability of failure. Q is equal to 9 by 10. Okay. Now the question is find the probability of 5 men selected at random. Means here the sample is of 5 men. Like in previous example, there were n number of trials. The value of n was 10. Here the value of n is 5. Here the sample is of 5 men selected at random. So the n is equal to 5. And the probability of 5 men selected at random, 2 will live for 70 years. The 2 will live for 70 years is here. See, the probability of R is equal to the probability of 5 men selected at random, 2 will live for 70 years is equal to the value of R success is 2, because out of 5 men only 2 will live for 70 years. That is our success. R is equal to 2. Now the formula of binomial distribution is NCR into P raised to R, Q raised to n minus R. N is 5 here. Sample of 5 men are taken. So 5 C, R is here 2. 5 C 2 into P raised to P is here 1 by 10, P raised to R, R is 2, so 1 by 10 raised to R into Q raised to n minus R, Q is here n minus 10. So n minus 10 to the power n minus R, n is 5 and R is 2, so 5 minus 2 is 3. So the power of 9 by 10 is here 3 and the power of 1 by 10 is here 2. Now you solve this, calculate this value 5C2 into 1 by 10 raised to 2 into 9 by 10 raised to 3. Using calculator, you can easily calculate this value 5C2 combination into 1 by 10 raised to 2 into 9 by 10 raised to 3, and the calculated value is 0.0729. So this is the probability of 5 men selected at random. 2 will live for 70 years. This is your answer. So using binomial distribution, you can calculate the value easily. So here I discuss binomial distribution with examples. So this session is over here. Thank you. Thank you.